Whoever wins physics wins the planet.
Yeah, this is such an amazing story of American exceptionalism.
I want to note that the National Science Foundation is the #1 resource for investment and funding towards basic and fundamental science research that is not it does not need profit in order to be successful.
No,
and it's the substrate by which the government really does a lot of these basic science and early frontier research things, and then they hand it to the private sector to go make billions of dollars.
Yeah. It's because the frequently fundamental science, you can't have a horizon of 10, 20 years, even 50 years sometimes.
Or quarterly, for that matter.
Yeah, you can't expect corporations, way back in the day, if you told any of these pharma corporations, hey, why don't you go put in some research to discover how bacterial immune systems work. How does a bacteria defend against viruses? Right? Any of these pharmaceutical companies, these private sector, would be no, because I don't know, why would I do that?
Right.
The NSF said, yeah, that sounds pretty interesting. Why don't you do it? Out came CRISPR. Out came all of the gene technologies that we have today.
Which are going to literally revolutionize every aspect of human life.
Yes. Save millions of lives, make millions of lives better. We need to have the technology in the first place. And the NSF is incredible. And it's like America's secret weapon for why we've been ahead since post-war.
And this is
post-war, World War II.
Part of the reason we're even able to have the story we're talking about here about the biggest black hole collision ever is because we have these tools.
Yeah,
these
we have
this that were funded by these programs.
Yeah. We have these two observatories called LIGO, Large Interferometer Gravitational Observatories. It's basically these giant underground facilities, one in Washington State, one in Louisiana, that measure the distortion in length of a 3-kilometer long tunnel. Okay, so you got a tunnel that's 3 kilometers long, and we want to measure whether that tunnel shrunk by 10 to the minus 18 kilometers. So we got a 3-kilometer tunnel, and we want to see if it got shorter by a little bit bigger than a proton.
This is so insane.